Today we define the speed of light. C is equal to 299,792 and 458 meter per second. This is the definition. This is the definition of the speed of light. Okay, because we know that light travels with a constant speed, so we give it the number. We give it the number of that constant speed, and now we define that the light is travel as the 299,792,458 meter per second, and the reciprocal of this number is the time that the light travel 1 meter, and we use that to define the distance 1 meter. Okay. Please note that the way I write down the speed of light, or the in the definition of the length, and when I write down the speed of light is equal to the 099, and I give the space between the number and 792, and I give the space between number and 458. This is the way in science is a scientific way to write down the wrong number, the number that has many digits. We do not use the comma as in the financial, but we use the space to separate 3 digits and to group 3 digits. Like if you write the number in the financial, you use the comma to separate 3 digits, right? But in science, we use the space to separate 3 digits. Okay, so in using this format, the speed of light is written like this. You can see the space here and the space here. Okay, so that is the definition of length. We use this speed of light here, so I may rewrite this as S equal to CT, and if T is the reciprocal of 299,792 and 458, S is equal to 1 meter. This table shows the example of some measure length. You should be familiar with this kind of number, because it will be useful to give you the feeling of how large or how small an object is. For example, if you talk about the size of the hydrogen atom, you can see that it is about 10 to the minus of 10 meter. Okay, so you can get the feeling of how small the hydrogen atom is. But if you talk about the radius of the Earth, it is about the 10 to the 6. Okay, so that's how big the Earth is. Okay, so this gives you the useful information. Next, let's move to the standard of mass, which is the kilogram. The kilogram is defined as the kilogram is defined as the mass of a specific platinum iridium the platinum iridium alloy cylinder this cylinder is kept and the International Bureau National Bureau of Weight and Measure in France but in this picture is not the original standard mass. In this picture it is a copy. It is a copy at Nice. Nice is a national institute of standard and technology in USA. Okay. So this is the institute that keep the national standard for the USA, and they do the copy of the standard kilogram from France to use in their country. The kilogram is only one is the only non-natural standard. Today we still cannot find a way to define the mass using the natural standard. Scientists try to do that, but not success now. So we need to use the standard kilogram. So you can see that this is not universal, not natural in the sense that it is not natural in the sense that we have the artifact that we say that this is 1 kilogram. So if you want to compare your standard, you have to go to France and to compare your mass with the standard mass. So you cannot create the standard anywhere in the universe. You have to go back to to France every time you want to compare your standard. So this is not the national standard. Okay, and the reason that we use the platinum iridium because it is the unusual stable alloy. The platinum iridium is a very stable alloy, so it means that we can keep it and approximately it's not depend on time. So you can see that the standard still not depend on time because it approximately, nothing is perfectly stable, but it approximately is very independent of time. Okay, and when you look at this figure, you can see that the standard kilogram is kept in a very special condition, very controlled environment. Okay, it is kept in the double bell jar. Okay, you can see that there are two bell jar to keep the standard kilogram, and it's also those two bell jar is also kept in the wall. Everything is kept in the vacuum, so you have to control the condition of the standard that it will not change in time. This is one of the disadvantages of using the non-natural standard, because you have to keep the condition to be the same today, next year, next month, next 100 years. That is very difficult.